My name is Kevin, and I'm from the South Korea. I'm also known as some philosopher in the South Korea community. It's not about some technology, right? It's about some philosophy. Okay, anyway, before the start of the presentation, I would like to say thank you for my devotion of my teams. They gave us very good intuitions about these ideas and developments of it. And Ethereum is very awesome and great projects, and you can build many types of decentralized applications on it. But there is some limits on the privacy. Anybody can see the transaction, who sends the money to whom, and anybody can check out and anybody can code whether somebody code a specific smart contracts or not. And there are many researches to overcome these types of situations. And zk-DEX is very great projects, and Maximus, and Mobius, and JIT, either Aztecs, sometimes are like that. But these projects are just mainly focusing on just transferring the simple tokens. So that we would like to develop these ideas from simple transfer tokens to the decentralized exchanges. Then it's going to become awesome, right? Right. So before the start of the zk-DEX, we need to understand how the DEX works. This is the first steps. The maker Bob makes an order with the source tokens and target token and a price and amounts. It means Bob wants to sell his either or die. Wants to sell his either to buy a die, right? With the price at 10. The second step is on text on orders. Alice, the takers, can find out the orders, and she takes this order with the source token, target token, and a price and amount. The source token, target token are different than the making order, right? And then if these two orders are matches each other's, then these orders can be we need to overcome to build some private decentralized exchanges. These are the concepts that can be used to overcome these two problems: the smart node, then viewing key, and a settlement with the general logic probe. In order to understand how the zk-DEX work, you guys need to know the background information, background knowledge about the zk-DEX. And zk-DEX started some 1.5 years ago, maybe, at the Singapore hackathon. And in this project, all the dice need to be converted into so-called secret note. And this note consists of PK and values. And PK are the public key of the node owners, and values of the node, values of the die in it. And these nodes are stored in a blockchain as hashed and encrypted. So only the owners of the nodes can know the exact amounts of it. And in order to span this node, and the owners of the node need to submit a proof that he has a secret key that corresponds to the public key of this node. And he needs to know the exact values of the node, right? And in the zk-DEX, in our project, we added some pure variables on it. And the PKs and values are same to the previous one. And the type is the token types of this node. And PK is the viewing key of the senders, and salt is just a random number. And smart is the flag that shows whether this node is smart or not. And we turn the smart node, we turn the secret node into some smart nodes. And I'm going to explain it as smart flags more. The PK is the node hash, and if the smart is true, then this node becomes some smart node. The difference between the secret node and just secret node and smart secret node is that the node owner can be the owners. I mean, it's a little bit complicated, but only the account can be the owner of in secret nodes. But in our smart node, node owners can be the owner. how can I speak in it? For example, like in a smart contracts, for example, in some ERC20 tokens, on token owners can not only be about some external account, but also be the smart contract account, right? In a mosaic models. And to spend the smart node, you need some GKP of the secret key that correspond to the public key of the public key. I mean, the owners of the nodes. And it's a probe about some that you have that owner of the node, right? Right. So some second one is the exact values of the nodes and exact the values of the public key. I mean the node hash, any other data of the nodes, VK sort concept like that. One good features we can get from this smart node is that you can send a smart node to somebody without knowing their exact address, right? Because node owners can be the nodes. You can send your node not to anybody, to any somebody's node, right? Okay, by using this concept, we can define these types of, these data structures of owners. It consists of 7 fields, from maker viewing key to the parent node. I'm only explaining it in details. Maker viewing key is the viewing key of the maker, so that only maker can see the contents of these orders. And maker node is the node that is going to be traded with the takers. And source token, target token price is already I explained it. And taker node to maker is the node that is going to be swapped with the maker node, right? Yeah. And parent node, okay, so parent node of the taker node to maker, parent node of the taker node to maker, and it's going to be explained on later part of this presentation. All right, let's start with the making orders. A maker, the Bob, makes the order with the maker viewing key, maker node, source token, and target token, and a price. And except for the price, these informations are hidden behind the general knowledge proof computations so that nobody knows exact values of these except for the price. And these orders are listed on the market, and Alice can find these orders, and he sends taker node to makers. It's a node that she wanted to trade with the maker's node, and the information about the parent node. The important part in this step is the taker node to maker is the maker's node, because the taker node to maker is just a smart node, and I already mentioned smart nodes owners can be the node, right? So when Alice takes on orders, the taker node to makers, the PK of the taker node to maker is the maker's node. And taker node to maker is encrypted with the maker's viewing key that the maker already submitted, and taker view key is included in the taker node to makers. So these orders can be settled later. Okay, the last step, settlement step, is a little bit complicated, but it consists of several logics. First, maker decrypts the taker node to maker with the maker's viewing key, so that maker can checks out, maker can knows the exact values of these orders. And there are 2 possible cases about some amount of it. If Alice wanted to trade with Bob's amount is less than Bob's, then there are going to be existing some changes, right? And if the Alice amount is less than Bob's, changes goes to Bob's. If Alice's amount is greater than Bob's, the changes goes to Alice, right? These are the 2 logics described here. Okay. And this slide shows in different ways of making trade. This is the Bob's and this is the Alice. And they have their own nodes. If in this case, Bob has the DAI and Alice has the Ether, right? And Bob wants to sell his DAI in orders. And this node becomes some maker's node, right? And Alice wants to sell his Ether node, and it's going to become as a taker node to maker that I already defined earlier of these presentations. And the taker node to maker's owner is maker's node. So in this case, Alice doesn't have to know the address of the Bobs, right? Alice just need to know the hash of the maker's nodes, and nobody knows the makers. Nobody knows who are the owners of the maker's node. So it's becoming some private. Right, there are two possible cases about some changes, and this is the changes goes to, in this case, the changes goes to Bob. In this case, changes goes to Alice, right? Okay, this is a different way of explaining this part. Bob wants to sell his one Ether to buy a die at the price of 10. It's a little bit cheaper. And Alice takes the orders with his die to buy an Ether. But he just wanted to sell the 5 die, right? So these maker node and taker node to makers are on the market, and the changes goes to the Bobs. And based on the informations of the parent nodes, the maker nodes belongs to the new node to takers. It's about some parent node. Then Alice can claim this node, and the owner of this node can be then Alice. The important things and important features of this protocol is that nobody knows who are the makers and takers of the owners, because it is a smart node. And the second important features is that how much did they trade each other? Nobody knows how much did they trade each other. Because these nodes are based on a secret node that developed by the zk-DEX. But there is some user experience problem, because in this system, only settle orders can be done by the maker. That's why we introduced the broker concept. But there is some trade-off between the privacy and the conveniency. So in this case, the maker viewing key can be the broker's viewing key, so the brokers can exchange these two nodes. All right, this is maybe the last part. There's a limitations in either public blockchain. It's not becoming some Ether 2.0, right? And the single zero-knowledge proof computation consumes more than 7 million gases. It consumes more than 80% of the single blocks in the blockchains. So, and after the Istanbul hard forks, it reduces maybe half, maybe 30% of it, but it's still large and still huge. In order to guarantee the privacy, lots of transactions need to be submitted to the blockchains. So currently, this is not practical yet. So that's the reason why we need the second layer solutions, more scalable, and it's still decentralized, and it's still Turing complete. All right, all the logics are written in these papers, bit.ly/zk-DEX, and you can check out the logics of how this works. And it's not about some concept, we implemented it, including the front-end part of it. And this is some additional information about our projects, demo videos and papers and GitHub. Thank you. Any questions?
When it will be in production on mainnet? When it will be in production on mainnet?
When it's going to be when it's going to be deployed on either mainnet, right? There is a limits on the Ethereum gas, block gas limits. in the system. So I think it's possible to deploy on mainnet right now, but it's not practical yet. So we need some more scalable second layer solution to cover these protocols. And that's the reason why our team building some second layer solutions for Ethereum. The tokamak network is that. Right. So any questions? Nope. Okay, thank you.